Да, коллеги, всем привет.
Hello, guys.
Так, это мы сильно перескочили. Собственно, меня зовут Кирилл Демин, я являюсь
I'm
руководителем
Kirill Demin.
систем мониторинга
I'm the head of Monitoring System Division.
продолжение доклада коллег. То есть коллеги рассказали, что писать правила не так просто, нужно учитывать много различных
Yeah,
нюансов.
indeed, Informzaschita. So you've just heard that it's important to consider various difficulties or potential traps as you develop your correlation rules. So I'm here to tell you about how you can actually do the testing of the correlation rules.
Подобного не было. То есть много говорят, как
I'm not sure you will learn a lot of new things, but surprisingly enough, so many people talk about developing your correlation rules, but very few people talk about testing them, particularly doing it in an automated way.
много контента и как его потом тестировать.
Which is important, particularly you have lots of rules.
Как проектная команда мы пишем контент на
Now,
ежедневной
my team works for a commercial SOC, which means that we develop this content on a daily basis for ourselves and our numerous clients. So imagine we got some correlation rules developed, and the big question is, well, will these correlation rules work? Will they actually detect an incoming attack? How do we know that? How can we prove that? Now, clients, depending on their maturity, will address this question differently. Like if you have SIEM or if you have SOC, you can actually find your answer here in this list in order to see which maturity stage you're at as a company. So where do we start and what are we testing? Is that identification of attack or the rule as such? Well, our answer to this question is that, well, we're here to detect attacks as they're coming in, but we also take into account that the content we're developing should be capable of effectively detecting cases where threat actors try to go from point A to point B employing a particular technique. How do we do that? And where do we start?
Поговорить немножко, такое отступление сделать к жизненному циклу контента.
This will be
такая большая сложная схемка, можете ее там сфотографировать, потом посмотреть. Она вообще из
a sidetrack, so to speak. Now, I took this presentation from a different report where we explain, how we developed this whole thing, leveraging PDCA and OODA methodologies or frameworks. Now, in particular, we are interested in the check stage. Well, because we certainly want to make sure that we can properly test the content we develop. Testing architecture is shown here. Now, the key component is the orchestrator. We already had GitLab, so we're using it. Another key component is the Invoke Atomic framework, which provides a huge database of updatable tests you can run across a bunch of operating systems, including Windows and Linux. But then in 2024, that's not really enough. Now, we wanted to be able to monitor these alerts in SIEM or EDR.
Поэтому здесь мы усложняем нашу схему и
So it gets more complicated.
GitLab еще выполняет различные API-запросы.
Now, as part of the testing process, GitLab will also do some API requests, getting information from CM on whether there was an alert or not. And it's also nice to have some dashboards for the bosses of yourselves, because sometimes we run numerous simulations and we want to know how many of them were successful, how many not so much. That's why we deploy Grafana here, in order to see generalized metrics when, for example, there are numerous attacks underway. Now let's look at individual stages of it all, starting with orchestration, done by GitLab, I think. Now, it was only natural
отвечает определенный пайплайн. То есть у нас есть
to have a separate pipeline for emulation of a particular technique, and maybe a set of sub-techniques associated with it in every pipeline. We have 3 stages, and they are somewhat consistent with how Atomic works and how we interact with the CM system. Stage 1 involves checking whether we have enough privileges to do an attack emulation. So we use an SSH key here to address a host running Atomic. Then we invoke a particular technique, for example, 15.46.0.0.3, VMI subscription, VMI. And then, we get a response from Atomic telling us if we've got enough privileges. Next stage has a sequence of 3, shall I say, methods of mounting this attack. So you could use well-known frameworks such as Empire and maybe external scripts and more files. So you can see that we are mounting this attack step by step. Next, we get our result, which we are going to parse going forwards to see if it has been successful. Now, Atomic has got this nifty feature that we can automatically delete artifacts. So that, whatever was generated by this quasi-malware, well, because it was used as part of the emulation process, naturally. So 3 jobs are being performed here. So at the Git level, each of them is considered a separate job. Now, stage 3 involves a SIEM alert. And, this is some kind of strict mapping here. We initially came up with a correlation rule that we expected to work with regard to the techniques that we were launching here. It's shown in the pipeline, and we use the API to check if it got triggered, in the time slot when we launched the technique. And, if it doesn't get shown there, then we obviously need to fine-tune our rule. So imagine that our rule got triggered, maybe some rules from the off-the-shelf content, so to speak. Now, what are the options here? We've checked the prerequisites, so to speak. All tests, have happened. Alerts got generated, which shows that we're well protected. It can also happen that, SIEM hasn't given us any feedback, although the attack must have happened, and we need to fine-tune the correlation. Moreover, it can happen that, the attack was not mounted because we were missing some writes. Next, we do visualization through Grafana. Now, these are pretty standard dashboards, but I think they were a pretty good fit for what we needed, because we wanted to visualize the techniques and the sub-techniques. So what gets visualized here is the jobs we have in the pipeline. And this is the list. What's successful, what's not, total number, the time it took. Now, there is certainly room for improvement here.
Как оно вообще встроилось в наше командное взаимодействие? То есть
Now let me tell about how we built it into our team interaction, cyber drills.
Все это придумали и реализовали. Было вот так. То есть этап check.
That's always like previously. So this is the check stage from the lifecycle. So people come up with the rules, they test some of them manually, test others semi-automatically, for example, manually. They can launch some technique from Atomic. Well, they will, fine-tune some false positives. And maybe they discover something else invoking the help of pen testers. And, if you want to double-check something again, you got to do it manually again. But then, when you've replaced a lot of content, you may want to test it all in a single go. And naturally, you don't want to do it manually. You want to do it with a single press of the button. It's got much more complicated now as far as the logical layout is concerned, but in terms of, daily work, it's much easier for sure. Particularly for the more complex cases where you need to sort of generate an event to be detected, you would have to go to the registry and so on and so forth, and it's complex, it takes forever. But, breach attack simulation, you can find in Atomic, well, I'm calling it BAS because what we have is, closest to BAS. So we can download it from the base database and think that Atomic contains.
Можно было бы придумать какие-то интересные метрики.
We could have come up with some interesting metrics that would show how much we have reduced our own workload, how many man-hours have been saved, but I didn't want to, come up with fancy metrics. Instead, I simply took the reports of Russia's largest vendors, showing the most popular techniques used by threat actors. Indeed, such techniques can be found in Atomic. Atomic contains everything that we wanted to test. Next, we calculate the total number of different ways you can invoke these techniques. This is what we got. The total number of TTPs is limited, but the number of ways you can employ them is measured in hundreds. Now, if you ask a single person to do it manually, it will take a long time. If you want it to be repeatable, can we imagine how long it was going to take? So I think it goes without saying that we have been able to save quite a lot. It is certainly convenient. Now, the result we currently have is certainly not final. We continue developing the system. Now, want to do backward integration with EDR, not just SIEM. We also want to fine-tune the way we develop our own test cases, and also try to expand the pipelines that we have. At the moment, we only have 3 stages. Each of the 3 is covering all different implementations of a given TTP, but we want to cover other TTPs as well. So this will help us improve what we have in Grafana, but also work, I think, on GUI, on visualization. Now, why am I telling you all this? Now, the big idea behind this presentation is that rules got to be tested, and few companies do it. Even fewer companies automate this testing process. So you can use your favorite orchestrator. You can use an existing framework from Invoke Atomic. You can put it all in your test infrastructure. You can link it to your favorite CM, and you will have, a test rig, so you don't really need to use Caldera or Bay for a standalone commercial product. That's easy. And what I've shown here, can be easily built incorporating your current tech stack. So test your rules, get more secure. Thank you very much. I hope I've been able to spark some interest. Yes, thank you, Kirill.
Есть вопрос. Ты как раз упомянул про BAS.
You have mentioned BAS. So the question is, why not use a ready-made BAS? I think it's up to you guys. Why not develop your own CM or use an open source CM? Some people will choose that, and they will be using their own CM. And others, will buy an off-the-shelf BAS or CM. But there are geeks out there, who prefer to roll their sleeves up. And, they will develop something on open source and they will love it. So there are different options for different people. Good. What about Splunk attack range and detection lab? Have you considered any of this? I know what you're talking about. And we have considered Caldera, and we've considered some commercial BAS solutions, but then we decided what not be necessarily easier, but we decided it would be a better fit for us to use Invoke Atomic, because we sort of already knew how to develop test cases for Invoke Atomic, and we generally felt good about it. Which means that everybody goes their own way. One more. What's the distribution of techniques and rules across repositories? Do you use a single large repository, or many smaller ones.
Здесь пайплайны как бы лежат в одном репозитории.
Now, pipelines are stored in one repository. If we are talking about correlation rules, what's importantly, not all SIEM systems
Поэтому как бы хранить и то, и другое в гите можно не со всеми
you
Если ваша CM-система позволяет хранить
our interface to Git. If your system supports Git, that's great. But some SIEM systems don't do that. If your vendor is just planning to support Git,
надо подождать.
well, then probably you'll have to wait.
У нас
And
в Git
what's
только
your
инфотесты.
case? Well, what we have on Git is just the tests.
CM и отдельно.
The content is on CM and it's also stored separately. Last question.
Тесты должны ли содержать только скрипты, приводящие
Should tests contain nothing but scripts?
необходимо создавать дополнительные условия для проверки?
Or will you also need to sort of create extra conditions?
Ну, изначально тесты, которые есть в Атомике, они уже
Now, the tests you can find in Atomic, they already do attack simulation. And the artifacts
они удаляют.
you can find in the system
Если хочется создать
will be
или
deleted.
модифицировать какой-то тест-кейс на свое усмотрение,
If you want to create or modify an existing test case, yes, this can be done.
Спасибо.
Thank you.
Спасибо, Кирилл.
Thank you, Kirill.